Okay, let's get on to the rating systems. We can measure reaction type or response type, or we can measure severity. Now, response type is usually measured as resistant, moderately susceptible, and susceptible. I often use the interpolations as well. RMR, MRMS, MSS, or S. Some people just use M. In the field, you will know, those of you that work with us, it's not always easy to see the textbook examples. You can see it's intermediate, it's moderate, but it's not easy to say it's moderately resistant or susceptible. And you can also use SMS to say that most pustules on this particular entry are susceptible, and a few are still moderately susceptible. You can use MSS, showing the range goes from moderate infection or moderate reaction types to susceptible ones. It's the modified Kopp scale. Kopp scale was first, I think, published in 1892, 1895. And it's a severity index, 0 to 100. And I'll show this in the next slide, the actual infection levels are 0 to 37%. You will ask me why, and I will explain that to you now. And also, we're getting on into area under disease progress curve. Important to record your host growth stage at the time that you take the notes. So the modified Kopp scale was published in 1948 by Peterson et al. It was published. I think most of us know the paper. We all use it, and we cite it quite regularly. I think this must be one of the most cited papers in Rust literature. I tried to look it up on Scopus to see how many times it's been cited, but Scopus does not go back to 1948. So maybe once they've updated all the records, eventually we will know. So they have 4 pustule sizes. And then the B scale would be the severity scale that we use in the field, 1 to 100. And then they have pustule size 1, pustule size 2, 3, and 4. And that is the actual values that we enter into our field books or our tablets, what we use to do the scoring. And you can see each of these correlate or correspond to a different value, and that goes from 0.37 to 37.0. And Peterson, who developed this scale, actually assumed that when you have a 37% of plant tissue covered with symptoms, you actually have 100% infection, considering the mycelium inside the tissue that you can't see with the naked eye. So that's how they came up with this particular system. Now, since this was published in 1948, I wondered about a year or two ago how accurate they were. And now you get image analysis programs that can actually determine quite easily, what the actual infection or the difference is between black and white. So I went ahead and for each of these levels, I used an image analysis program, and I calculated the image analysis value, and then I did a regression to see whether the image analysis or whether the scale values, the published scale values, actually explain the image analysis values, and I got an R-square of 0.99999. So they were very accurate. And I then read up how they did it, which is not important now, but they had some pretty fancy equipment in the 1940s for calculating this and using mathematics.
I think there is software as well available by which you can scan and convert it.
They used an instrument called the planimeter, Planimeter, planimeter. It's a mechanical instrument, and they use that to calculate the areas on large pieces of paper. They're very accurate. So I thought I was going to prove them wrong, but they proved me wrong. And then also there are many, I think, examples. This is from the CIMMET guide, where you can see basic examples of 5, 10, etc. I know many people would read a 3, some would read a 7. I like 15, I like 25. there's some subjectivity in it, I guess, and as long as you're consistent and using the same system throughout. And these would be the response types: resistant, moderately resistant. You can see small pustules, slightly larger pustules for the MS class, and then, of course, your big, full susceptible ones on the bottom right there. Another system that's used is what they call the coefficient of infection, and that is when you want to combine the severity and the response type into a single value. So the constant value for resistant would be 0.2, MR 0.4, then 6.8 and 1. So what you would do, if you have a trace R, you have 1 times 0.2, and your CI, or coefficient of infection, would be 0.2. If you have a 10 MS, you will have 10 multiplied by the constant value for that particular category. It's 10 times 0.8, and you get a value of 8. So that can also be used quite effectively if you want to combine into one.